So section 4.2 is adding, subtracting, and multiplying polynomials. We're not going to worry too much about adding and subtracting polynomials. I'll talk about it in class a little bit, but these examples are mostly going to cover multiplying polynomials and then what's called binomial expansion. So example 1 is multiply 2x squared minus 3x plus 5 times x minus 2. So we just need to take each of these three terms and multiply it by the two terms in this parentheses. So I'm going to take 2x squared, multiply it by x. So 2x squared times x would become 2x cubed. And then 2x squared times a negative 2 would become negative 4x squared. Negative 3x times x, that would become negative 3x squared. And then negative 3x times negative 2, that would become positive 6x. 5 times x is 5x, so plus 5x. And then 5 times negative 2 would become negative 10. And then from there, we're just going to combine like terms. So just all the terms that have the same variable to the same exponent, you can combine by addition and subtraction. So this is kind of like going back and using the same concepts that you would use for adding and subtracting polynomials. So just basically combining like terms. So I only have one term that has x to the third power, so there's nothing to combine that 2x cubed with. But for x to the second power, I have a negative 4x squared and I have a negative 3x squared. So if I combine those, I just need to add the coefficient. So negative 4 plus negative 3 would be negative 7x squared. And then now I have a 6x and a 5x. Those have the same variable, same exponent, so I can combine those by addition. So 6 plus 5 is 11x. And then negative 10 is my only like constant, so I'll just bring that negative 10 down. So 2x cubed minus 7x squared plus 11x minus 10. And then for number 2, it's x plus 2 cubed. So unfortunately, you can't just like distribute the cubed in. You do have to write like x plus 2 times itself plus 3 times. So x plus 2 times x plus 2 times x plus 2. And then what you want to do is you want to FOIL the first two, or it doesn't have to be the first two, but FOIL two of the binomials, and then we'll have a problem just like example 1. So we have to kind of take it step by step. So if we FOIL just the first two here, so x times x is x squared, x times 2 would be plus 2x, 2 times x would be plus 2x again, and then 2 times 2 would be plus 4. And then I still have this x plus 2 after it, or times x plus 2 after it. And then I can simplify, or I can combine like terms in here to make it a little bit easier to multiply again. So when I do that, x squared just comes down, 2x plus 2x is 4x, plus 4 times x plus 2. And then from there, I can go ahead and I can multiply this trinomial times a binomial like we did up here. So x squared, I just need to multiply each of these terms by both the terms in this parentheses. So x squared times x, that would become x cubed. And then x squared times 2, that would be 2x squared. And then we can move on to the 4x. So 4x times x is 4x squared. 4x times 2 would be 8x. Then we can move on to the third term. So 4 times x is 4x. And then 4 times 2 would be 8. And then you can combine like terms, so there's only one x cubed term, so that just comes down. So 2x squared and 4x squared, those are like terms, I can combine them, just add the coefficients to get 6. So plus 6x squared. And then 8x and 4x, those are like terms, they have the same variable, same exponent, so I can add them. 8 and 4 is 12, so plus 12x. And then 8 is my only constant, so I can bring that down. So plus 8. And then that's as far as I can simplify this. And then for 3, x plus 2 times x minus 1 times x minus 3. So same thing as up here. We have to kind of pick two binomials to FOIL, and then we can multiply it by the third. So I'm just going to focus on x plus 2 and x minus 1. So x times x is x squared. X times negative 1 is negative x. 2 times x is positive 2x. 2 times negative 1 would be minus 2. And then times x minus 3. And then I just need to simplify like terms in here to make it a little bit easier when I go to multiply it again. So I can combine the negative x and the 2x. So the x squared will come down. Negative x plus 2x is just positive x, or positive 1x, and then minus 2 times x minus 3. And then now I can multiply this trinomial by the binomial like we did up here in example 1. So I'm going to take my x squared and multiply by both these terms, then move forward to x, then move forward to negative 2. So x squared times x would become x cubed. X squared times 3 would be negative 3x squared. X times x, and we're moving on to x, so x times x is plus x squared. X times negative 3 would be minus 3x. We can move on to the negative 2. Negative 2 times x is negative 2x. And then negative 2 times negative 3 is positive 6. And then from there I can combine like terms. So x cubed, that's the only one of those, so I can just bring that down. Negative 3x squared, or I have a negative 3x squared and I have a 1x squared, so I can combine those. This is like negative 3 plus 1, so it would become negative 2x squared. I have negative 3x and negative 2x, so I can combine those. So negative 3 plus negative 2 is negative 5x. And then I can bring down my plus 6. And then for the last example, we're going to use Pascal's triangle, which if you haven't heard of Pascal's triangle, it's a triangular array of binomial coefficients. And it's just kind of like an arrangement of numbers that helps us expand something like 2y plus 4 to the third, or it could be even to higher powers without actually like multiplying it all out. So Pascal's triangle, it starts with a 1 at the top of the triangle, and then the second row is 1 and 1. And then now with each next row, you take the sum of like the numbers in the row above it. So the first number in each row is always 1. And then our next number would be the sum of the two numbers above it. So the sum of 1 and 1 is 2. And then the last number in each row is 1. And then so also each row like has the same, like that row's number of numbers, I guess. So like the first row has 1, the second row has 2, third row has 3, the fourth row will have 4 numbers. So 1 is the first number, and then for the next number I have to add 1 and 2, so 3. And then for the next number I have to add 2 and 1, so also 3, and then it ends with 1. And then for the fifth row, so 1, and then I'll add the 1 and the 3 to get 4. I'll add the 3 and the 3 to get 6. I'll add the 3 and the 1 to get 4. And then 1 at the end. And then next row, 1, add 1 and 4 to get 5, add 4 and 6 to get 10, add 6 and 4 to get 10, add 4 and 1 to get 5, and then it ends in 1. And this keeps going on forever and ever and ever. So if you wanted to expand it, you could. But we actually just need this row right here to expand 2y plus 4 to the third power. So whatever exponent you're expanding to, that matches up with, I guess, the second number in each row. So like since we're expanding to the third power, we're going to focus on this row, and this row is going to give us the coefficients of our expansion. So what we have to focus on is we have to think of what's our first term in the binomial and what's our second term. So our first term is 2y, and our second term is 4. So when we expand this, the numbers in this row, so 1, 3, 3, 1, those are all going to be coefficients, like the number in front that we multiply by our variable or by whatever our term is. So I'm going to leave a space for my coefficient, And then you're going to take the first term, so 2y, and you're going to raise that first term to the third power. So whatever power you're expanding to, the first term starts off being raised to that power, so 2y to the third. And then you're going to take the second term, and that's going to start at the 0 power. So you don't like technically need to write that because anything to the 0 power is 1, but just so we can kind of like start to see the pattern. And then I'll move on to my next term. I'm going to leave a space for my coefficient. And then as we go across, the exponents on the first term, first term go down, and the exponents on the second term go up. So next it'll be 2y to the second power, so it'll go down from 3 to 2. And then 4 to the first power, it'll go up from 0 to 1. And then plus, I'm going to leave a space for my coefficient. It's going to be 2y. It's going to go down to the first power. And then 4 will go up to the second power. And then the next one, I'll leave a space for my coefficient. 2y is going to go down to the 0 power. And 4 is going to go up to the third power. So on the first term, we started at the number we were expanding to, so the third power, so 3, 2, 1, 0. And then the second term, 4 starts 0, 1, 2, 3. And you just go up to until you get to the third power on the second term. And then these numbers in Pascal's triangle, so 1, 3, 3, 1, those are coefficients. So 1, 3, 3, 1 will go across here. And then now it's just time to simplify. So 1 multiplied by anything is just the same thing. Obviously, you don't really need to worry about that 1. But 2y to the third power, that means 2 to the third power times y to the third power. And you don't necessarily need to show this up if you can do it in your head, but just so we can kind of see, since this is just factors in here, you can kind of like distribute the 3 for lack of better terms. It's not multiple terms inside the parentheses, so that's okay. And then 4 to the first power is just 1, or 4 to the 0 power is just 1. Anything to the 0 power is just 1, so we can move on to the second term. So 3 times, and then 2y in parentheses squared is like 2 squared times y squared, and then times 4 plus 3 times 2y to the first, so this is just stays as 2y, and then 4 squared would be times 16. And then the last one, plus 1 times 2y to the 0 power. Anything to the 0 power is just 1. So this 2y to the 0 is just 1, and I'm just worried about 4 to the third power now, which is 64. Now I can just kind of keep simplifying. 2 to the third power is 8. So 2 times 2 times 2, and then 8y cubed. And then for this term, 3 times 2 squared, so 2 squared is 4. So 3 times 4 is 12, and then 12 times this 4 would be 48, so plus 48 y squared. And then 3 times 2 is 6, and 6 times 16 is 96, so plus 96y, and then plus 64 comes down. So you would get this same answer if you wrote this out 3 times and like FOILed it and then continue to multiply. So like 2y plus 4 times 2y plus 4 times 2y plus 4. Or you could do it this way. And you can imagine like the higher the exponent is on the binomial, the more valuable this strategy becomes. So like say this was like 2y plus 4 to the 10th power. You would not want to write it out 10 times and then like do all that multiplying. So this way is very, very helpful for higher exponents when we're expanding binomials.